The project title is CoCoWa, that is a collaborative content-based watchdog for detecting selfish nodes. See the abstract. The combination of service-oriented applications with a runtime service binding and mobile ad hoc networks with a transient communication topologies brings a new level of complex dynamisms to the structure and behavior of software systems. Current methods of dynamic dependency discovery developed for use as fixed networks assume that dependencies change slowly. We describe a new method designed specially for this environment that allows the engineer to trade accuracy against cost, yielding dynamic snapshots of dependencies relationship. We evaluate our methods in terms of the accuracy of the discovery emergencies. Let's see the problem identification of this project. An interdependencies is a more complex relation between services that relates an incoming interdependencies to an outgoing interdependencies. In the sense, interdependencies reflect more detailed insight into the nature of dependencies between the service than do the basic interdependencies. In existing system, the technology used for developing web service can be classified into two main categories: represential state transfer and the simple object access protocol web service. This classification is based on the architecture style used in the implemented technology. SOAP is an object-oriented technology that defines a standard protocol using the enhancing XML-based messages. It is defined as a protocol specifications for exchanging structured information in the implementation of web service in computer network. Its main disadvantages is existing methods based on their stability assumption cannot adequately cope with such high levels of dynamically non-stricken resource constraints. It allows the transfer of large amounts of trace data from the collection points into the central analysis elements, which is prohibition in resource constraint methods. Let's see the data flow diagram of this project. First, we have to see the neighbor estimation. Choosing anchor points is a crucial step of the data gathering process since it determines the efficiency of energy transferring and the latency of data gathering. A trivial scheme is to simply visit all the sensor nodes, gather data through signal port transmission, and use the sensor to forward data back to the static sink through long-range communications. However, these schemes could trigger several new problems in our data collection and wireless recharge scheme. Let's see how the service dependencies works. Service dependencies change is a response to the dynamic of the network. A higher rate of the change in service dependency should lead to the greater number of irrelevant dependencies included to discover DG. Service dependencies may change not only due to normal computational progress, but also to optimize the use of otherwise equivalent services. In this way, the service system adapts to the network dynamics such as large fluctuation in communication quality and availability. Network dependencies. The dependency network approach provides a new system-level analysis of the activity and topology of the direct networks. The approach extracts causal topological relations between the network nodes and provides an important step towards interface of causal activity relations between the network nodes. This methodology has originally been introduced for the study of financial data. It has been extended and applied to other systems such as immune system and semantic networks. Analyze the result. The performance analysis of the proposed scheme to increase throughput and decrease delay. Communication overhead describes the observation of an average or record for the base station to make any decision whether a node has been replicated or not. Computation and storage overhead. Define computation and client storage overhead as the average number of public key signing and verification operations per node and the average number of clients that need to be stored by the node. Let's see the project. Click address button, you will get the user IP address and the MAC IP address. Click network status, you will get the network status. For the signal status, click this one. Click next button to view the next form. To get the source IP address, click this one. You will get the source IP address and your source memory and the processor name and the MAC address of your source details. To open a file to transmit the path to the receiver, click any of the text file. It will generate the hash function for your files. To know the packet information, click this one. You will get the file size and the file extension of your transmission. Click next button. To create a node, click this one. You will get the nodes created in a random manner. To connect the node from each other, click this one. It's get connector. To know the value transmitted of each node, click this one. Click next button. To know the weighted of the source and the destination nodes, click this one and choose the selected path to transmit your file. Click source node range. It will calculate the distance from your connection 1 node and the connection node to the destination node. Click destination node range. It will show the calculation method here. To click the next button, click here. Choose one source node and the destination node. I am choosing the B node as a source node and the destination node as a H node. Click add node button. It will view the nodes. Click any of the 3 possible paths. I am choosing this one and click the connecting node button. To detect the Watchdog selfish node, click this one. This is the Watchdog detection selfish node. It will be denoted in red color. Click next button. To send in a possible way, you have to select the add transmit path button. Click energy save button. It will show the energy possible way. Let's see the performance evaluation. Click time analysis button. It will show your energy graph. Click transfer file button. It will show the graph. Thank you.